Hi, this is John Linneball from John Linneball Tutoring, and this is Barron's Chapter 6K, Quadrilaterals and Other Polygons. For the best results, I suggest you use the Barrons SAT 30th, 29th, or even the 28th edition. This video covers pages 589 through 590 in the 30th editions of Barrons SAT, the Premium SAT Study Guide. The page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous editions. You shouldn't use an edition older than Barron's new SAT from 2016 in any event. Not everything in the book is in these questions. Do read the book. You'll find things in these subchapters that you may not find in the review questions from after the subchapters, which is what I'm going over with you in these videos. The older editions of this book can be had cheaply, if not for free, from used booksellers. Kids have already taken the test in public libraries. They sell old editions, or you can borrow the current edition at the public library. Really, seriously, when they sell old editions, they're about a dime at libraries near me. So anyway, if you plan to use a library copy or buy a new edition, I suggest you start early. There's no worse feeling than needing a library book someone else has checked out, or trying to buy a review book that's sold out when you don't have time to wait for them to be restocked or returned to the library. And you should start early anyway. This is going to take some work. So, question 1, page 589. In the figure above, the two diagonals divide square ABCD into four small triangles. So we can see the four triangles here. 1, 2, 3, 4. What is the sum of the perimeters of those triangles? Well, we see from the figure that the square's side length is 2. So that means this diagonal here is 2 root 2. AC is also a diagonal. It's going to be equal in a square. So that's also 2 root 2. So remember, a square's diagonal splits it into two 45, 45, 90 triangles, and you should know the side ratio lengths. If this is 2, this is also 2, so BC is 2, CD is 2, and then DB is going to be 2 times square root of 2. The ratio is always 1, 1 root 2, so that this is 2, this is 2, this is 2 root 2. And so the two sides of each triangle are going to be just root 2. Why? Because the diagonals bisect each other, so this is root 2, this is root 2, this is root 2. So obviously we can say this is 2, and then this side is square root of 2, this side is square root of 2. So this is just going to be 2 plus 2 root 2. Since there are 4 equal small triangles, we just multiply that by 4. So you get 4 times 2 plus 2 root 2, which equals 8 plus 8 root 2, which is choice C. Question 2, page 589. If the length of a rectangle is 4 times its width and the area is 16, what is its perimeter? Well, let's have W represent the width. This isn't drawn to scale, but I just eyeballed it, so it should be fairly close. Anyway, let W represent the width. The area is 4W times W, which is 4W squared, equals 16. So we divide both sides by 4, we get W squared equals 4. Obviously, W is equal to 2, since you're not going to have a negative length. So then the perimeter is 4 times 2 times 2 plus 2 times 2, which is going to be 16 plus 4. I'm sorry. Yeah, 16 plus 4, which is 20, which is choice C. So let's go on to the next thing. Question 3, page 589. If the angles of a 5-sided polygon are in the ratio of 2 to 3 to 3 to 5 to 5, what is the degree measure of the smallest angle? Well, first we should know that the sum of the internal angles of a polygon is always going to be n minus 2 times 180, where n is the number of angles or sides in the polygon. In any polygon, the number of angles is going to be equal to the number of sides. You might also call the angles vertices since they're corners. So vertices, angles, sides, always the same number for a polygon. So therefore, the sum of the internal angles in the polygon here is going to be 5. They tell you it's 5-sided. 5 minus 2 times 3 is 180. Notice they could have also told you it's a pentagon, and you should know that that's 5 sides. But anyway, 3 times 180 is 540. So we know the total is 540 degrees for the internal angles. If we add the numbers in the angle ratio together, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 5 plus 5 is 18. We get 18. So if we add an x to the end, we get 18 times x equals 540. So x, the measure of each share or part, is 540 over 18 equals 30. Are we done with the smallest angle being 30? No, we are not, because it's 2. So we have to multiply 2 times 30 to get 60, which is choice B. Question 4, page 589. Questions 4 and 5 refer to a rectangle in which the length of each diagonal is 12, and the diagonal forms a 30-degree angle with a side. What is the area of the rectangle? Since they didn't give you a diagram here, it's a really good idea to draw a diagram, especially since that's kind of hard to visualize in your head. So we draw a rectangle like I did here, and we say, okay, so we know that the diagonal is 12, it forms a 30-degree angle, so you can pretty quickly figure out, hey, this is 30, so since every rectangle has 4 90-degree angles at the corners, or the vertices, that's 30, that's 90, so this has to be 60. Hey, it's 30, 60, 90. This is a special right triangle you should have memorized the side lengths for, or the side length ratios. So if this is 12, we know this has to be half of 12, because it's a shorter leg, so that's 6. And then the other leg, the longer leg, is going to be the shorter leg multiplied by square root of 3, so it's 6 root 3. So this is 6 root 3, this is 6 root 3. So then the area is just going to be 6 times 6 root 3, because this is the length, this is the width, so we end up with 6 times 6 root 3, which is 36 root 3, which is D. Question 5, page 589. What is the perimeter of the rectangle? Since we know the width is 6 and the length is 6 root 3, the perimeter is 2 times 6 plus 6 root 3. So we're going to add this to this, and then we know there are 2 6's, 2 6 root 3, so it's just 2 times the sum of 6 and 6 root 3, which is going to be equal to 12 plus 12 root 3, which is choice 6. So hopefully from these problems you should see that you should always draw a diagram for a geometry problem when they don't give you one. If you think you're good enough to do it in your head, go ahead, but you're probably taking a risk. It's easier just to scrawl a little diagram on your test booklet page rather than just try to do it all in your head. Especially if you're having trouble seeing what it looks like, do draw it out and it should become a lot clearer. There's a reason they didn't give you a diagram, because they figured it would be too easy if they did give you a diagram, so please draw one. Question 6, page 589. The length of a rectangle is 5 units more than the side of a square. They just say 5 more, so fine. When you see it's 5 with no unit specified, just say unit, unspecified unit, whatever. And the width of a rectangle is 5 units less than the side of the square. So if the area of the square is 45, what's the area of the rectangle? We can draw a diagram like so. Again, just, drawing a square really quickly, saying area is 45. Then you can quickly say, oh, okay, well, the side length has to be the square root of 45. No big deal. And so the length is the square root of 45 plus 5, and the width is square root of 45 minus 5. So since we know the side length is root of 45, and the length is square root of 45 plus 5, the width is square root of 45 minus 5, we just multiply them together like any other two binomials. And hopefully you know the difference of squares. If you have a plus b times a minus b, or in this case, square root of 45 plus 5 minus, square root of 45 plus 5 times square root of 45 minus 5, then you know it's just going to be equal to 45 and then minus 5 squared, which is minus 25, which is equal to 20, choice A. If you don't know the difference of squares, please learn it. It's just a plus b times a minus b is equal to a squared minus b squared. Know that for the test. If you don't know it, or you're panicking or something, you can just FOIL it out. You get 45, then the outer is going to be minus 5 root 45. The inner is plus 5 root 45. Those cancel out, and then you have minus 25. It's easier if you just remember the difference of squares, but whatever. 45 minus 25 is 20, choice A. Question 7, page 589. Questions 7 and 8 refer to the figure in which M, N, O, and P are midpoints of the sides of rectangle ABCD. So here's rectangle ABCD, here's MNOP. What is the perimeter of quadrilateral MNOP? Well, we know MB is 4 and we know BC is equal to 3. Since these are midpoints, that means MB is 4 and AM is 4, so that's 8. BN is 3 and C is 3, so that's 6. Okay, so the quadrilateral MNOP is composed of the hypotenuses of 4, 3, 4, 5 triangles. Hopefully you just recognize that. If you don't, just know you have to figure out the hypotenuse. So this is a squared plus b squared equals c squared. 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. So that means this is the square root of 25, as is this, as is this, as is this. Of course, the square root of 25 is 5. You should be able to figure that out in your head very quickly. If you can't, know your squares. If it's on the calculator section and you have that problem, use your calculator. Anyway, that means each side has length 5, so 5, 10, 15, 20, or just 4 times 5 is 20, which is choice A. Question 8. Okay, page 589, question 8. What is the area of quadrilateral MNOP? All right, so how do we figure that out? Probably the easiest way to do it is first just recognize that since this AB is 8, BC is 6, 8 times 6 is 48. So, and we can also see that MNOP's area is just going to be the area of the rectangle, which we just figured out is 48, minus the area of these 4 triangles. Well, okay, we know the area of this triangle is 4 times 3, which is 12, and then we have to divide it by 2. So that's just going to be 1/2 times 3 times 4, which is just 6. Since there are 4 of them, 6, 12, 18, 24. 4 times 6 is 24. So the area of MNOP is 48 minus 24, which is 24. Another method is you can split MNOP into 2 triangles with a base of 6 if you want the base to be this. Since this is 6, this also has to be 6. Remember, it's a rectangle. And this is 8. And so we can say, well, since it's going to be 2 triangles, this is 6, this is 4. 6 times 4 is 24, but remember, to get the area of this triangle, we have to multiply it by 1/2. So that's going to be 12. Since this is identical, this is also 12, so 12 plus 12 is 24. Guess if you're a little quicker on the draw, you could just factor out the 1/2 and the 2 and just go, okay, this is 6, this is 4, boom, that's 24. I don't care how you do it. I would probably, well, I do care. I'd probably just do it using the kind of slower method with the 2 triangles to make sure you don't make any mistakes. Anyway, it's pretty easy. This is 6, this is 4, multiply that, 6 times 4 is 24. Times 1/2, you get 12. 12 plus 12 is 24 again. There you go. So 48 minus 24 is just 24. If you do it the first way, or you just compute this directly, and you get 24. Sounds good? Sounds good. Let's see if I can get this slide to move. There we go. Question 9, page 590. Questions 9 and 10 refer to the following figure in which M and N are midpoints of the 2 sides of square ABCD. All right, first thing we see is this is a square. So if this side length is 2, that means all the other side lengths are 2. We just square 2 to get 4. That's why it's called squaring it. Anyway, so we know the area of the whole square is 4. And so then we know quickly that the diagonal has to be 2 square root of 2 because the diagonal splits a square into 2 45, 45, 90 triangles, and using the Pythagorean theorem, and hopefully you just memorize these side ratios. If this is 2, this is also 2. This is 2 square root of 2. If this were 1, it would be 1 root 2. And so we know that same thing here, that since this is 2, AM has to be 1, MB has to be 1. Why? Because they tell you M is a midpoint. And since this is 2 and N is a midpoint, this is 1 and this is also 1. So then we know that this has to be 1 times square root of 2, so it's just square root of 2. So the perimeter becomes very easy because we know this is 1, we know this is 1, we know this is root 2, and we know this is 2 root 2. So this is going to be 2 plus 3 root 2. It's 1/2 plus root 2 plus 1 plus 2 root 2. Combined like terms, we get 2 plus 3 root 2, which is choice B. And all right. Question 10, page 590. What is the area of the shaded region? Well, we can use all the calculations we did for question 9 to answer this question very quickly. First, since we already know the area of the square is 4, so we know the area of triangle AMN is just 1/2 times 1 because the base and the height are both 1. You multiply by 1/2. So this area is 1/2, as you can see I wrote in my copy of this book. And then the area of triangle BCD, well, we can see that's 2 times 1/2. So 1/2 times 2 is 1. That cancels out. 1 times 2 is 2. So then all we have to do to find the shaded region is we just subtract 2 from 4 to get 2. And then we subtract 1/2 from 2 to get 1.5. So 4 minus 2.5 is equal to 1.5, which of course expresses 1.5, so it just makes you do one more piece of work, which is choice A. It's one more chance to make a mistake because they love you. All right, anyway, question 11, page 590. In the figure below, ABCD is a parallelogram. What's the value of y minus z? All right, so we can see that, well, first of all, you need to know that y is equal to 3x minus 5 and z is equal to 2x minus 15. Why, no pun intended, is because when you have alternating angles, that is, ones that are not connected by a side, they're diagonal to each other, they're equal in a parallelogram. So we know y is equal to 3x minus 5, z is equal to 2x minus 15. So angles that are next to each other have to add up to 180. So we know y plus z is 180, z plus 3x minus 5 is 180, 2x minus 15 plus 3x minus 5 is 180. So we can pretty easily go, okay, 3x minus 5 plus 2x minus 15 is 180. Combining like terms, we get 5x is equal to 200, x is equal to 40. So y is going to be 3x, so that's 120 minus 5, so that's 115, and z is equal to 2x minus 15, which is going to be 80 minus 15, which is 65. 115 minus 65 is y minus z, which is equal to 50. Question 12, page 590. Here's a principle to know. The sum of the external angles of any polygon taken one at each vertex is 360. So if you take this one, this one, this one, this one, and this one, those add up to 360. And it's the same if you took the other ones at each vertex. Those would also add up to 360. Since we're taking 2 at each vertex, you just multiply 360 times 2, you get 720. So it's really easy if you know that principle. So remember, the sum of the external angles of any polygon taken one at each vertex is 360 degrees. If you take 2, it's 720. If you take 3, it'd be 1080. And so on. Anyway, if you have a question like this on a multiple choice part of the SAT and you have forgotten this principle, just estimate the angles, add them, and pick the answer closest to your estimate. When I did this, I chose 60 because, I don't know, that was just my guess. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That adds up to 600. That's not a great estimate, but maybe the answer choices are far enough apart that 600 is the closest, 720 is the closest answer to 600. Either way, it's a lot better than just guessing blindly, or even worse, leaving an answer choice blank. Don't do that. There is no penalty for guessing on the new SAT, so please, even if you have no idea, at least fill in something. Okay? Question 13, page 590. The only way to do this one is to find the area of both rectangles in terms of x. Let me read the problem to you. If in the figures below, the area of rectangle ABCD, so it's this one here, is 60, what is the area of EFGH? That's really super easy. Well, it's not really, actually. It's really hard until you figure out what the trick is. But anyway. Okay, to find the area, we'll just do it in terms of x. So we have x plus 1 times x plus 3. If you use FOIL, okay, first is going to be x times x squared. Outer is 3x. Inner is 1x. Last is 3. So we have x squared plus 4x plus 3. EFGH is x plus 2 times x plus 2. You've probably memorized that. If you haven't, that's okay. Just use FOIL again. Curses, foiled again. Ha ha ha. Anyway, x squared is x, x times x is x squared. Outer is 2x. Inner is 2x. 2 times 2 is 4, so you end up with x squared plus 4x plus 4. So notice that x squared plus 4x plus 4 has to be one more than x squared plus 4x plus 3. So since they tell you the area of ABCD is 60, and EFGH is just one more, it's plus 4 rather than plus 3, EFGH must have an area of 61. Any other way you try to solve this problem will not work. Believe me, I tried. And also note that the figures aren't drawn to scale, so you can't even try to measure it using a little ruler you made from an edge of your answer sheet or something. it's just not going to work. So question 14, page 590. How many sides does a polygon have if the measure of each interior angle is 8 times the degree measure of each exterior angle? Since all the interior angles are the same and all the exterior angles are the same, it's a regular polygon. That means each exterior angle is the same. It's the average measure of each exterior angle. So if we're assuming that we're taking one exterior angle per vertex and let n be the number of sides, which is also the number of vertices, then we know the sum of all the external angles is 360, so 360 divided by n is the measure of each external angle. We also know the sum of the interior angles is n minus 2 times 180. One interior angle is n minus 2 times 180 over n, and the sum of the angles, which is going to be the sum of the angles, n minus 2 times 180, divided by n, which is the number of angles. So from the problem, we know that each interior angle is 8 times the measure of each exterior angle. So n minus 2 times 180 over n is equal to 8 times 360 over n. Notice we can multiply both sides by n, so that disappears, that disappears. So we just end up with n minus 2 times 180 is equal to 8 times 360 over 180, because we're just going to divide by 180. And so then n minus 2 is equal to 8 times 360 over 180, which is of course 2. So 8 times 2 is 16. So then n minus 2 is equal to 16. So then n has to be equal to 18. Should be pretty easy to follow. If not, you can ask me. I'll explain it to you, or you can just look at the answer explanation in your Barron's book. All right. Question 15, page 590. In quadrilateral WXYZ, the measure of angle Z is 10 more than twice the average of the other three angles. What is the measure in degrees of angle Z? Well, we know the sum of the internal angles is 4 minus 2 times 180 equals 360. So obviously 4 minus 2 is 2. 2 times 180 is 360. Therefore, Z is equal to 10 plus 2 times W plus X plus Y over 3, which is going to be the same as 10 plus 2 times 360 minus Z, since we know that W plus X plus Y plus Z has to be equal to 360, then W plus X plus Y is going to be 360 minus Z, so it makes it much easier because we only have one variable in one formula. So, solving the equation, we get 3Z is equal to 30 plus 720 minus 2Z, so then we just combine like terms, we get 5Z is equal to 750, because 720 plus 30 is 750, and we're adding 2Z to each side, so 5Z is 150, and Z is equal to 150. Did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? It's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. I also don't have anywhere near 1,000 subscribers. Last I checked, I had about 695. So if there's a copyright issue, please contact me. I don't think I've used anybody's copyrighted material. It's certainly nothing that wouldn't be covered by fair use, but hey, if you've got a problem, contact me. And for the same reasons, you're not only welcome, but encouraged to share links to this video, put it in playlists, because I'd really like more views and more subscribers. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I reserve the right to delete comments from those who specialize in destructive criticism. People are just trying to troll, or things that are off topics, spammers, disturb people, somebody wants to sell a product or promote something that has nothing to do with my channel. And if you'd like to contact me, you can call me on my cell phone, which is 415-623-4251. You can text me at that number as well if you like. Email me at john@johnlinnebaugh.com, or you can mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. Thanks very much for watching. And if you need more contact information, you can find me on Facebook at www.facebook.com/Linnebaugh Tutoring, all one word. Instagram is instagram.com/john.linnebaugh.tutoring. My office number is 415-986-7355. My email, again, is john@johnlinnebaugh.com, and my website is johnlinnebaugh.com or johnlinnebaugtutoring.com. They'll both take you to the same website. All right. Hope you're having a good day. Thanks a lot for watching this.